Hello everyone, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this short lesson is a thing called a struct, spelled S-T-R-U-C-T. So I'm just going to type this in here, S-T-R-U-C-T. That's how it's spelt, and we'll be coming back to exactly where it fits in a program in a moment. But just to introduce the topic, first of all, we've seen types before, like ints and floats and characters. They're your basic types, and we know that they take up a certain amount of space. So depending on the system, an integer might take up 4 bytes, and a float might take up 4 bytes. A double might take up 8 bytes, or something like that. And a character usually only takes up about 1 byte because that's all that's required to do it. So those are your basic built-in types. And we've seen that we can have arrays of those types, which is a collection of the same type. So you can have 10 integers or 10 characters or 10 floats or something like that. What you can't do is you can't have an array that has ints and floats in the array as one. Okay, so so an array would all have to be of the same type, and that's why when you type it, you have to say something like int array. So I'm not giving it a great name, but 10, and that's an array with 10 items. There, as you can see, and they're all integers. You can't have some of them floats and some of them characters and some of them integers. Okay, so we've seen those before, and the other thing we've seen quite more recently is pointers. And pointers are obviously a variable that holds the address of one of these types or one of these variables. So it might have an address of an integer or the address of a character or the address of a float or whatever. But what we're going to look at in this lesson, as I mentioned, are a thing called a struct, and these are an aggregate type. And what I mean by that is they're a collection of related items, but the items can be of different types. So what I mean by that is they can be a collection that can have ints and floats and characters all in together. Now, there's nothing to stop you having only integers in there or only floats or only characters, but that wouldn't really make a whole lot of sense. You could normally do that by another mechanism. Now, when I say it doesn't make a whole lot of sense, it's really just when it comes to that, you can do one or the other. It's a bit like anything you do with a for loop, you can do with a while loop. So there are different ways of doing these things. But in general, when we're talking about structs, what we normally like to do is we'd like to put different types in there together, but that have a relationship to each other. Okay, so we put those in a thing called a struct. And we'll see later on in further lessons that we haven't said goodbye to pointers by any stretch of the imagination. We can actually use pointers to point to these structures, and that would make sense as well to do that. Okay, so struct is short for structure, and it holds different types together that are related to each other. So what we're going to do is we're going to look at an example and see how to declare or define it, and we'll also see how we're going to access it later on if we want to do something with it. Okay. So to define it, what I'm going to do is I'm going to just make my standard program here, and I'll just pause while I'm doing that. Okay, so I've got my standard kind of program written there. So if I want to define a struct, let's say I'm going to define one called employee. So I do so as follows. And obviously, because I'm calling it employee, you can guess it's got something to do with employee details. Now, of course, this current version of DevC does a lot of, it finishes things off for me. So for example, when I wrote the struct here, and then I put the opening brace of it, you'll see that it made a closing brace, but it also made something that's very easy to forget, and that's the semicolon that goes on the end of the struct. Because we don't normally put a semicolon on the final brace of a function or on the final brace of a for loop or an if statement or anything like that, but we do put it on the end of a struct definition. So as you can imagine, with a name like employee, what we're suggesting is that it's going to have details about a particular employee. Okay, so what we would normally have for an employee is we might have their first name, and because their first name would have several characters in it, we're going to give that an array of characters up to 20. I think it would be rare that you would have somebody's first name have 20 letters, but you would often have, particularly, not non-European names that would maybe 2 or 3 names together, or that you would have to maybe put in as a first name or something like that. So it's probably quite reasonable to have at least 20 characters there. But you may find that that's too many, and that you could save some memory by having that as smaller. And again, for the last name, it would be rare enough to have anything above about 20 characters as well. Now, later in the course, we will be looking at a situation whereby what happens if you have things that are larger, or if you don't want to make something. In other words, if you had something that was possibility of being larger, you don't want to set this up as being 30 or 40 just on the off chance that one employee might have a very long name. So there are other ways around that, but that's for a later part of the course. What else could we say? So we might put down a character for gender. In other words, are they male or are they female? We're using a character for that because we don't want to use anything larger. Now I was going to put down a double for hourly salary, but we're unlikely to need that level of precision for an hourly salary, so I think a float would do. Got this example from, I think it was the book that I've recommended you to. I don't have it beside me at the moment, but I've taken some notes. So I think it's from the Detail book. So I think they had a double there for that, but I'm going to change it to a float simply because I don't think anybody's hourly salary needs to have that level of precision, the double precision, because you're only going to have two spots on the right hand side of the decimal place in this, which tells us the number of cents that they might be making for their hourly salary, and on the other side it's unlikely that their hourly salary is going to go into the millions or billions, so therefore it doesn't really make sense to have it much larger than that. So that's a struct there that we've created for an employee. And as you can see, it has 5 different things involved in: a first name, a last name, an age, a gender, and an hourly salary of different types. So there's character arrays in there, there's a single character, there's an integer, and there's a float. But you can see how they're all related because they're all related to an individual employee. And of course, there are other details that you could hold on an employee as well. Now, this doesn't take up any memory space yet because this is a little bit like an int on its own that hasn't been given a variable name. The struct is literally just the prototype for this. It's not, or the blueprint for it. It's not an actual variable itself. So the next thing that we're going to do is we're going to make a particular example of this, or a variable of it. So we're going to say struct. You need to say this. There are ways around writing the struct in front of it, but we'll be coming to that in a later lesson. So for the moment, we write struct employee, and I'm going to call this one Sean. Okay. And all I'm going to do for the moment is, if I just did that there, struct employee Sean, that would now make a variable of type employee called Sean, and it would have memory associated with it. So we would have to create the memory for that, but we wouldn't have any information in it yet. I'm going to show in a moment how to apply all the information to that as part of our initialization here. But what I'd like you to understand is how much memory one of these variables takes up, because previously we normally knew on a particular system how much memory an integer took up, or a character, or whatever. So how much space does one of our structs take up? Well, you've got to figure that out from the basic types that we have. So characters normally take up 1 byte on our systems, and so the first 2 arrays are 2 sets of 20. So I'm just going to write that 20 plus 20. Added to that is the age, which is an integer, which is I think 4 bytes on this system. Gender is the character, which is only 1 byte on this system, and float would be 4 bytes. Altogether, that comes to 49 bytes is how much space you would need for a variable of this structure type. So it's a much larger amount of space than you would normally take up for a single variable type of int or something like that. Okay. Now, what I can do is when I'm actually declaring it here, I can also define or initialize the information in it, and I can do so by doing an initialization, a little bit like we would do for the arrays or so on. So it's gone and sorry, I should have had it's gone to give me a second semicolon there for some reason. I think it was because there was already one there. I think that's why it did that. So what you would do here is you would fill out the details. So let's say, for instance, Sean is the first name, comma. Keep them separated. Now, Mullery is the second name. And I've decided I'm going to be 20 years old, though I may be not exactly telling the truth there. I'm male. You're going to have to take my word for that. And I'm going to pretend that I'm on a very modest salary of €8.65 per hour. Okay, and we can see that that's been put into these braces here, and I think I need that semicolon on the end. I'm fairly certain there, and that's in that case as well. Now, so that's filled in all the information on that, and we're going to take a look at how to print that out. So to print it out, I'm going to, and this is going to take quite a number of printf statements here. So I'm going to say employee name is %s for the string, and of course because we've got two of them, we've got a first name and a last name. We're going to say %s, %s. I'm going to put two of them there. I'm going to put /n so that we go on to a new line, and at that point I'm going to write the following. So take careful note of this. What we say is Sean, because Sean here is the name of the variable of that type. Okay, it's Sean. And it's going to be Sean dot. So the dot is the operator that you use in order to access a particular element of a struct. So it's first name, comma, Sean dot last name. Okay. Now, any of you that have done an object-oriented language like C++ or Java will probably be familiar with this type of idea of putting in the dot in order to access an individual element. You used to do with objects in an object-oriented language. A struct is not an object because it doesn't have functions associated with it, but it was from the struct that the idea of a class and an object were actually designed in C++ and Java later on. But a struct is not, and an item of it is not an object as such. So that'll print out those two details. I also want to print out the age. So we'll use an integer for this, is %d years old. And again, we'll go Sean dot, and this time age. I'll say employee's gender. What I could do is I could have a little if statement here that checked what the gender was, and then decided to either print male or female, but I'm just going to say employee's gender and just print the M. Okay, but you can imagine how it would be quite easy to add the code to decide to print out either male or female. Employees. %f for a float. And I think that's all the information. Now I'm just going to save the file. And we're not in embedded programming anymore, so I'm going to make a new one for C Programming 201. Now I'm going to call this struct test. Definitely don't call it struct. You don't want to get mixed up with the actual keyword name. So struct test.c, and I don't think I put that in the right directory at all. I think I just made the directory and didn't save it in it. So I'm just going to do a save as again. C Programming 201 and save it in there. Remembering to put in the .c. And we're going to take a run of that. So execute, compile and run. See if we can find any errors in it. Nope. So you can see it's printed out. The employee name is Sean Mullery, so it's printed out the first two items of it. Employee is 20 years old. Employee's gender is M for male. Employee's hourly salary is $8.65 with 4 zeros on the end. So easy to solve that. We can just put a %.2f in order to limit ourselves to only 2 places, because we don't want to show anything more than that. Doesn't really make sense to, and we can see how it's come up there. Okay. Now, the other way to initialize it is, and I'm just going to show you quickly here. Actually, I'll do that as a separate video. So what I'll do is I'll end that video there just so that we have it, and then we'll just upload a second video showing you about some modifications that we can make to it.